everything that we've calculated so far from our T-charts is what we would consider theoretical yield. What's it mean for something to be theoretical? Yeah, that's right. What you think is going to happen, or in theory, if everything was perfect, this is what would happen. Okay, so out of our T-chart, we've calculated if we started with 10 grams of sodium hydroxide, then we should yield 20 grams of water, or whatever it is. Okay, so those are what we consider theoretical yield. It's what we can predict might happen. It's what in theory should happen, but is everything always a perfect world? No. So sometimes things go wrong in our experiments or in our trials. So it's not necessarily what actually happens. What we're going to do in this section is we're going to be able to calculate the percent of our yield that we actually yielded. Okay, what's it mean to have a yield? Not to slow down. What's it mean to have a yield of something? What you produce, right? Like a crop. Okay, so we would talk about crop yields a lot, right? My dad's a farmer, so we talk about the yield that we produced of our crop, what we expected and what we really came back with. And so it works the same way with stoichiometry. We're going to look at our percent yield, what we expected versus what we actually yielded. Okay, so this is the equation for percent yield that you should probably have down. Okay, the actual yield over the theoretical yield times 100 would put it in a percentage for us that we could see. Okay, actual divided by theoretical. Something that you should remember is that the theoretical number always comes from your T-chart. Okay, so theoretical starts with the T, comes from your T-chart. Actual is what you would actually produce. So if you did the experiment in a lab, the amount of product that you weighed out and that you found, that would be your actual yield. Okay, and you would compare it to your theoretical, which comes from your T-chart. Okay? All right. Let's try one here. Take a look at this balanced reaction. It looks like I already balanced it for you. Tell me what type of reaction it is first. Combustion. Good. We know it's combustion because we started with a hydrocarbon. We added oxygen. Our two products from a combustion reaction were carbon dioxide and water. Okay. How many grams of water will be formed if 36.5 grams of oxygen are used? Okay, how many grams of water will be formed if we start with 36.5 grams of oxygen? Okay, so when we solve this, what yield are we solving for here? Our theoretical or our actual? We're solving theoretical. Anything that comes out of our T-chart is theoretical, right? It's a perfect world. So let's go ahead and solve this, starting with what we know. 36.5 grams of O2. You get, all right, molar mass of oxygen gas is 32. Now we want to go from moles of oxygen to moles of water. And our mole ratio here is 3 to 6. Okay, because 3 to 6 right there. What's the molar mass of water? 18. Good. So now I'm left in grams of H2O, which is what I want. Go ahead and multiply across the whole top, divide by the whole bottom. Bless you. Why do neither of you have a calculator? Good. 10.26 good grams of H2O. Very good. That's what I had. Okay, remember that is our theoretical yield. So now it asks us, what's our percent yield if only 7.95 grams of water are formed? Okay, so to find our percent yield, we take actual over theoretical times 100. equals our percent yield. Okay, so what is the 7.95 grams here? The actual. Okay, it's telling us that we did the experiment and only 7.95 grams came out.
What is it, 10.26?
Mm-hmm. Okay, 77.5%. All right, what do we think about that percent yield? Good, bad, average?
Good.
Yeah, 77 is not what we want, right? In a perfect world, what would our percent yield be? 100, right? What happens if our percent yield is over 100? Something went wrong, right? In our experiment, something went wrong. We can't create mass spontaneously, right? There's some things that could cause our percent yield to be over 100 in a lab setting, things like not drying it out completely, having it contaminated. There's little things that could cause a percent yield to be over 100%, and we'll see that when we do our lab for this chapter. We're going to actually do a percent yield and limiting reactant lab. But if it gets to be over 100%, you might want to check your calculations if you're looking at problems like these. Okay. All right. Tells us if the reaction of 40.8 grams produces a 39% yield, how many grams of water can be produced? So now we're going to work backward from percent yield. Okay. Do we have here either our theoretical or our actual yield? No, we don't. But what can we solve for? We can find the theoretical from our t-chart. We have our percent. So our overall goal here is to find the actual yield. Right? We have our percentage. We have the ability to solve for the theoretical from our starting amount here. And then we're going to solve for the actual. Okay, so let's go ahead and do that. We'll do our t-chart first because we can't solve for actual without that. So we'd start with 40.8 grams. Do we agree with the molar mass there? Yes. Okay, good. Okay, so I got my theoretical yield to come out about 17.5. Do we agree there? Okay, so now how can I go about solving for my actual yield? Good, good. So we have our percentage. Percent equals actual over theoretical. Okay, but do we keep it in 39%? What do I need to do to that? I need to put it back to a decimal, right? Because in our original equation, we multiplied it by 100 to get it in a percent form. I want that back to decimal form. So I'd go 0.39 equals actual over theoretical, which is 17.5. Okay, and when my variable's on the top here, what can I do to solve for that? Multiply. Should we be getting a number smaller than or larger than 17.5? Smaller, right? We only formed 39% of what we should have, so we have to be able to check here that our number is in the ballpark of what it should be. Okay, questions there?